All right, greetings everyone. Welcome to the fourth part of the video now on section 5.3, continuing on looking at the relationships between sines, cosines, circles, angles, and points on circles. And we're building towards something I mentioned in the last video, which is the unit circle. And this next concept we'll talk about is important for understanding how the unit circle works. Okay, so first I want to talk about something called a reference angle of a particular angle. And as you see in the definition here, the reference angle is the size of the smallest angle to the horizontal axis from wherever we are on the circle. So notice over here in the picture, there are four angles. So there's one here, one here, one here, and one here. And even though, remember, we measure these angles by starting at the positive part of the horizontal axis and rotating counterclockwise, so like that for the first one, this for the second one, this for the third one, and then this for the fourth one. Okay. Well, the reference angle for each of those angles, even though the angle measures are different, notice the reference angle ends up being the same because it's the measure of the angle back to the horizontal axis. And when we measure reference angles, they're always measured back to the horizontal axis. And because of that, another thing we see here in the definition, our reference angles are always between 0 and 90 degrees, or 0 and pi over 2 radians. Okay, and reference angles are important because angles share the same sine and cosine values as their reference angles. Now the signs on those sines or cosines might be different, so pluses or minuses, but the values or the absolute value will be the same. So let me show you what I mean for that. So I'm going to go ahead and again draw my unit circle here. Okay, so that looks something like this, and I know that's terrible, but just bear with me. And let's say that I have an angle that starts here on the positive part of the horizontal axis, rotates around counterclockwise down to here, and maybe this is our terminal side here. Okay, and let's say that that angle is 240 degrees. Okay, so that's going more. Recall that this would be 0 degrees, this would be 90 degrees. Here, this would be 180 degrees. This would be 270 degrees. Okay, so notice the 240 there is in between 180 and 270. Now the reference angle for this angle, well, that's going to be the measure from the terminal side back to the horizontal, right there, so this angle. And how do you suppose we would find that? Well, note first of all, again, we went around 240 to get here. We know that this angle right here, this one, is 180 degrees. So it looks like that reference angle should be the difference between the two, right? So in this case, it would be 180 degrees, or excuse me, not 180 degrees. It would be 240 degrees minus 180 degrees, which would give us 60 degrees. So for an angle of 240 degrees, the reference angle is 60 degrees. Now here's why that's helpful, because as we mentioned in the last one, angles have the same sine and cosine values, except for a difference of signs from their reference angles. So if you recall, I'm in the first quadrant now over here, for a 60-degree angle, we saw in our last video that the cosine and sine there would be 1/2 and root 3 over 2. Okay, and in this case, remember that the 1/2, the x value here, that's the cosine value. And then the y value, the root 3 over 2, that will be the sine value. Okay, so then for 240 degrees, what we know is that the x and y values right here at this point will be the same as the x and y values for 60 degrees. So they'll be 1/2 and root 3 over 2. However, the signs will be different. And can we think about what the signs will be here for these? Well, we're down here in the third quadrant. So we're looking at x values along here, y values along here, and hopefully you would agree with me that in both of those cases they are negative. So for 240 degrees, we now know that the cosine is negative 1/2 and the sine is negative root 3 over 2. And again, we could figure that out using reference angles. All right, let's go to another kind of more general example. So here we're asked to find a second angle that has the same sine as 45 degrees. And then they want us to find another angle that'll have the same cosine. And I'll tell you right now, those will both be different angles. So again, go to our picture here. Draw in our circle. And we're starting now with 45 degrees. So we know that that's going to be here in the first quadrant. So that's 45 degrees, which also, if we practice our radians, that's pi over 4 radians. And again, we know that the cosine and sine of those are both positive root 2 over 2. And what we want to do now is find an angle that has the same sine as 45 degrees. So one for who the sine is root 2 over 2. Now, as we just learned, whichever angle it is we're looking for is going to have 45 degrees as a reference angle. And so what I'm going to do is, again, I'm going to label in these angles here. So that's 0 degrees, this is 90 degrees, this is 180 degrees, this one down here is 270 degrees. And I'm going to find angles in each quadrant whose reference angle is 45 degrees. So for example, here in the second quadrant, well, remember, reference angles are measured to the horizontal, so the reference angle in this case is going to be right there. And so to find the measure of the angle we're talking about, the one that will start here and rotate around to that terminal side, well, now it looks like that's going to be the difference between that and 180 again. However, this time 180 is larger, and we have to go back 45 degrees to get to the angle we're talking about. So if we do 180 minus 45, looks like that would give us an angle measure of 135 degrees. So this one is 135 degrees. And then we can also have an angle down here in the third quadrant, whose reference angle is 45 degrees, so down here. And now that's going to be an angle that's bigger than 180 degrees with a reference angle of 45. So in this case, we'll do 180 plus 45 degrees, and that will give us 225 degrees. And then finally, for the fourth quadrant here, we'll have another one. Again, remember, we measured the reference angle to the horizontal. So this would be 45 degrees here, but how will we find the measure of this angle now? Because we're not going to do 0 minus 45, because we know this angle has to be bigger than some negative number. So what we can do is recall that 0 degrees can also be the same as 360 degrees, right? Because if we start here at our positive part of our horizontal axis, rotate all the way around and end up back here, we've gone all the way around a circle, that's 180 degrees. Or excuse me, 360 degrees, so we know this angle is also 360 there at 0. And then to find the angle we're looking for, we could just do 360 minus 45 in this case, since we're going back 45 degrees. and that will give us 315 degrees as this angle measure. Oh my Lord, hold on. There we go. All right, so now we've got 4 angles in this picture who all have a reference angle of 45 degrees. What I want to do now is add in the sines and cosines for those. And recall that for all of these angles that have a reference angle of 45 degrees, their sines and cosines will be the same as what they are with 45 degrees, except for the signs might be different, right? The pluses or minuses. So we know that the coordinates for the sine and cosine in all of these angles are going to be root 2 over 2, comma, root 2 over 2, and root 2 over 2, comma, root 2 over 2, and this will be root 2 over 2, comma, root 2 over 2. But now we have to think about sines. So in the second quadrant up here, recall that because we're working along this axis here, all the x values are negative, so we know this should be negative root 2 over 2, and then we're working on this part of the vertical axis, and in that case all the y values are positive, so we can leave this as positive root 2 over 2. Down here in the fourth quadrant, we already know we're working along this axis where all the x values are negative. We'll be working along this one where all the y values are negative, so this should actually be negative root 2, comma, negative root 2. And then for the answer in the fourth quadrant, we're still working along this vertical axis here, so we know the y values should be negative. We're working along this horizontal axis, which is where all the x values are positive, so that'd be a positive root 2 over 2. And so now we have the sines and cosine for those 4 angles. We can find one for which the sine and the one for which the sine is the same as 45 degrees and one for which the cosine is the same as 45 degrees. So remember, sine is a y value, and here, because our y value is positive, root 2 over 2, we're looking for the one that has a positive root 2 over 2 with the y value, and that would be 135 degrees. So 135 has the same sine as 45 degrees. And then for cosine, we have to look at the x value. So that's going to be positive root 2 over 2. And the one of these 4 that we see that the other one of these 4 we see that the x value is positive root 2 over 2 is down there at 315 degrees. Okay. And the last thing would be we're asked to give answers in both radians and degrees. And I'll leave it up to you to convert these or check my calculations on these, but I believe for 35 degrees we would end up with 3 pi over 4 as the radian measure. And for 315 degrees we end up with 7 pi over 4. All right, that's it for now. Thank you for watching.